No, clever. It's where iReady would be located in. No, it says it should have clever. Okay, if it doesn't, listen. First off, if it doesn't have clever, log in with username and password. Guys, if you don't have clever, go online and search for clever, the clever portal or something like that, and do a login using your username and password.
I have.
Okay. So log in using your username and password. So search for clever. I hate the internet in this place. I don't know how we thought iPads in everybody's hands was going to work. What type of name? Yes. Log in as a student. Guys, you're going to have to search for your school in Clever. Like y'all should have gone into Clever to do the iReady testing. Sorry, can you need to sit next to Max so you can see how he's doing all this? Okay. If you want to do neither of y'all have iPads? Just pay attention to up here and follow along as best you can. Look on. Yo, Ty, you gotta know that password. You better be quick. All right. Come on, y'all. I need us to get into Clever. Or...
You just said DJ 1, 2, 3.
No. Okay, I was saying you need search for. Yeah, don't press. I guess. Yeah, you should already. Yeah. So guys, scroll down and look for Carnegie Learning. It'll probably be at the very bottom of the page under More Apps. Yep, that's it. CL. Okay.
E through F.
E through F. Why didn't you say E? E through H. E through I.
Okay. So if once you get logged in, oh man, we gotta get going. I know the iPads take a minute, but find Carnegie Learning at the bottom. Once you get into Carnegie Learning, hey guys, come on, right here. This is ridiculous. Focus. Get logged in. Scroll to the bottom to find Carnegie Learning, CL. I would heart it. So hold on one second. Yeah, you want to go to MATHia under Materials. So I would heart the Carnegie Learning. I would click on it. There you go. It's favorite resource. Don't press high school. The further you get, just click on it. Log in with an Active Directory. Yeah. Well, pay attention. Not Farrell. It sounds like you don't know your password. It looks like you need to restart. Okay, but restart your iPad. Hey guys, pause really quickly and listen. Do you know what the best solution to fix technology issues sometimes is?
Refresh.
Not just refresh. Restart the computer or iPad completely. If it is acting up, turn it off, turn it back on. I'm not saying it always fixes it, but I guarantee you if you were to call IT, that is the very first thing they would tell you to do. Now the goofy things with these iPads, I think to turn these off, you have to hold down the power button and the minus or power and plus, much like with your iPhones.
No.
Because I know like most of you have iPhones. Huh?
No,
You gotta hold it down. Okay. Regardless, I need y'all to click on Carnegie Learning if you are there.
I have that Google Pixel, it's like plus turbo.
Okay? So, listen up.
LT.
Hey, listen. Right now, the only thing that you will see in there is normal distributions because I was originally going to have y'all work on this and I couldn't get the mat cards. So click on Carnegie Learning, click on resources, but y'all are not going to do normal distributions. We're already done with that unit. I may have some of y'all work through some of that if, I'll talk about that later. But if I can get Carnegie Learning to work, alright, you will see what are called workspaces in that same spot. The workspaces that you will need, okay, turn it off, turn it back on. So you'll notice right here, you see I have nothing. It's because someone broke something in the system. Y'all's classes were there literally 2 days ago, and then I looked yesterday and it was broken. But that's a whole different issue. What you will look for is, they don't have anything really for this in the Algebra 2 content that's really good. So I went to the Algebra 1 content, and I'm going to have you all working through exploding constant rate. There we go. So you're going to go to this, and you don't have to do all this work because I'm going to set it up for you, but you're going to go into this section that says connecting arithmetic sequences and linear functions. And so I'm going to have you work through these workspaces. And you don't have to do all this, it'll just naturally pop up. I want you to be aware of a couple of things. This is what I'm going to have you be doing on Monday when Miss Estel is here. Either this or by paper to work on writing the equation of linear and exponential functions, okay? There are a handful of things about this that are really goofy. The really nice thing and the reason why I have you working through this is because on practice sets where you have to master a thing, they'll give you a step-by-step example so you can see what they're doing and how to connect it to the linear functions that we already have. Even if you say, hey, I'm going to skip that because I want to go straight to the problem, one, I don't recommend it.
Teachers, excuse this interruption.
No.
We need the sophomores with the last names that start with G and H to report to the library with their
Okay. So, right, well, they have to do it, and I get it. So right here, notice you will have, because the terms of the sequence blank, the sequence is blank, right? 9 to 8.75, 8.75 to 8.5. Oh, well, it's subtracting 0.25. Now, they're connecting to an idea called sequences that we are skipping because that is more of an Algebra 1 concept, but it very clearly connects. So, when I look at the sequence, notice how we're subtracting? That's going to be called a common difference, okay? Sorry, I planned to have this in there so you could at least work through one of these, but obviously it's not fully working. Because of that common difference, the function or the sequence is arithmetic. Arithmetic sequences are linear functions. So be aware of that. This starting thing is trying to get you to the idea of linear functions. But when we talk about, when you get to these practice problems, arithmetic sequences are linear functions. In a similar way, a geometric sequence, any guess? Quadratic, or not quadratic, sorry. The other one.
Linear.
Exponential. Remember, arithmetic are linear. Geometric are exponential. You'll just have quadratic sequences. Arithmetic and geometric are very unique. Now, the idea of some geometry, or there's a geometric mean that's also the idea it works with factors. Well, it ties into the idea of Pythagorean theorem and how we prove. One way to prove the Pythagorean theorem is by looking at geometric means, which is the product of factors. Anyways, eyes up here. Because you didn't say that in geometry, but that's not the focus right now. So I want y'all to notice, one, common differences, that's your additive rate of change. Common ratios, that's your multiplicative rate of change. And arithmetic sequences are linear, geometric sequences are exponential. That's just a little bit of vocab that you would need. Now, The other thing I'll point out here is they want an explicit formula. We didn't get to talk as much in this class about explicit formulas versus recursive because I didn't see y'all yesterday. But all of those equations that we have talked about up to this point are explicit formulas. And I want you to notice, do you have the y-intercept? What does the input need to be to have the y-intercept? 0. I don't have that. You can go backwards to find it, but what the MATHia is going to expect you to use is the point slope. Just be aware. It'll help you get there, but they're expecting that point slope. Technically they want, but again, this is why they have practice problems. So, I need to do this. Have common difference. It's arithmetic. A sub n is equal to 9 plus or minus 0.25. Actually, a minus. What? Oh. 0.25 parentheses n minus 1. Because they're using n as the input, you need to use n minus 1. And they're going to go through this idea of rewriting the function to get point slope, or slope intercept. Okay? And so it'll walk you through this to help you get there. And I did it quickly because I know how this is going to work. But they're going to show you the steps of distribution, right, and simplifying to get that point or the slope intercept form. All right, so it's going to walk you through it and help you build an understanding of how to write the equations of linear and exponential functions. Should you still probably get a piece of paper out and write through these things and write it out so that you have records of this on your own? Heck yes. Will it help you get the answers right? Heck yes. So 2 things to be aware of. The reason why these are called sequences, do you see how there's no actual line right here? Is it still a linear shape? Sequences have what's called a discrete set of points, meaning they're not connected, they're not continuous. That's why it's called a sequence. I'm not going to test you on that, that's just something to be aware of. The last thing I want to point out is this. You see this little bar up here where there's the little circles? So in order to get through this kind of workspace, you have to show mastery of each of these sections. I haven't decided exactly when, but whatever you don't finish on Monday is going to be homework that is due probably Wednesday or Thursday. Okay? Hopefully, check your iPads out, make sure that you know how to work on it from home, because Mr. Hinton did send an email out about how to use these at home. Okay, you can also use it during enrichment, things like that. This is designed 100% to give you the practice that you need with the supports. I didn't use any of the supports yet, because I just wanted to work through one, but I do want you to notice, right, so I'm done with this problem. Oh no, apparently not. Yes, it's a function. Okay. Oh my goodness. Can always be represented by a linear function. Now I'm done. When I go to a new problem, it's going to give me similar problems. I can go to step by step at the top. I can go to sample problems. I can get hints. And it's going to help you develop an understanding of how these things work. Also, if I click the wrong thing, okay, it gives me an X. I click it wrong again. Notice it gives me a hint here to help me move my understanding forward. Pay attention to the hints it gives. It's 100% designed to give you the immediate feedback you need to be successful. Any questions, comments, concerns?
Nope.
Thank you for your response. Anybody else?
We're doing this when?
Monday, Tuesday.
And we go to what?
Say again.
Like,
So you wouldn't go to any of those. That's for the standard normal distribution. If MATHia is working, I will assign it, and you'll see a completely different workspace
so it's
there.
not gonna be the workspace.
It's not going to be that named. I will have a name that says linear and exponential functions. And that's what you're going to be working on. Also, can you get out your notes on Monday and Tuesday to help you with some of these things?
Yes.
100%. I will go ahead and tell you, Tuesday is not going to be linear and exponential. It's going to be on domain, range, x-intercepts, y-intercepts, and identifying features of a function. But I've already worked through that workspace. It's very straightforward, and it'll help you understand all those different details better. And once you finish these workspaces, you can go back into them and do the practice again to help you prepare for tests and understanding checks, things like that. So this workspace is something very useful. Also, and not to be that guy, but just so you know, I can see how much time you spent on these workspaces in an analysis thing. So if you're fudging it and you're not doing what you're supposed to do, I can tell. So take it seriously. It's going to help you grow and learn.
What would you mean by that?
I can literally see the exact number of minutes that you have spent in MATHia.
Oh, I would say about 30.
Yeah, say more than that. All right. Okay. So at this point, let's get our textbooks out. We got a little bit more that we're going to start with today. Sorry, that took way longer than I planned. I feel like everything.
Oh, we're on textbook 1, right?
Volume 1.
Whoa. Let's go.
M1 dash, I think like 31 or something like
Why did you
that.
say that?
Yeah, because I shot it on mine.
He did say that. He did.
I've been telling y'all for a week to have your book. Literally last Friday I told y'all this.
Okay, give me Monday. I got you.
M1-31.
Can we write on paper?
You can write stuff on a piece of paper. Although I will say, what we're going to start with, y'all are probably going to just need to participate with others in your group. And I'll show you in a second. So M1-31. Faith, you're going way too far, bro. M1-31. It says lesson 3, samesies.
Please don't say that.
Okay. Oh, one other thing I will tell you is this. You can actually pull up, so where you went to MATHia, if you looked underneath that, it has textbook resources. You can pull up the textbook on your iPads as well.
That's what he said.
It's pretty nice.
So if I do my whole 10.
Huh?
So if I do my whole 10.
You can at least pull it up, but you'll want paper copies of a lot of this stuff. All right, so first things first, we are comparing multiple representations of functions, which we've already started to do. What are the different ways to represent functions? What are the different ways to represent them? Graphs. We can use function notation with what representation?
Tables.
Not tables,
Algebraic.
algebraic. Function notation f of x equals, that's part of the algebraic set. So we can use graphs, tables, and algebraic representations. And so please understand, this equation right here, that's algebraic. This graph right here, do they represent different things or the same thing?
The same thing.
They look very different though, don't they?
Yes.
So what would we call something that looks different but effectively is the same?
Relation.
Huh?
Equivalent.
They're equivalent. So relations are something else that we're going to talk about in a second, and that's very important. But we talked about this on Tuesday, that they may look different but they're the same. They're equivalent. And so we need to learn about how to identify equivalent functions. And so notice that is the very first objective, right? Identify equivalent forms of functions and various representations. We are going to learn about relations and function notation. So here are my objectives that I want you to see first. One of the very first things is understand the difference between functions and just relations. A function is a special type of relation. We need to know that difference. We want to identify linear, exponential, and quadratic functions in tabular, graphical, algebraic, and verbal representations. And we want to identify equivalent forms of functions, and we want to use algebraic properties to generate equivalent expressions. So it's going to take a little bit of time. We're not going to finish this today for sure, and we'll hopefully finish it on Wednesday when I come back. All right? So here is just a very quick getting started. Don't take forever on this because there's no, like, you have to be right or wrong. The question that I want to pose to you is to look at these different relationships, choose the relationship that does not belong with the others, and justify your choice.
Sophomores with the last name through the letter J need to report to the library with their iPad forms. That's sophomores with the last name through the letter J.
Come on, I know Ryan's the only one with it, but we need to have our book out. We're look at his book. Which one is different? Pick next page. Pick next page. I need you to pay attention when I go to this. So it's on the board as well if you need to look there. Okay, it's not which one sucks, which one's different and why.
That's why it's
Claim
different.
and have evidence, no.
Why is Y over there?
It's all five.
Yeah.
I think it's like
And then,
five, five,
I
five.
got my own number.
It's like six.
Oh, well, I don't get a 5. I think it's
E doesn't
I thought you were going to say Zeke has one, that one's
What's the relationship?
Yes, what's the word?
B is a regular.
Yeah.
B is a regular.
Y equals.
Gotcha. I'm looking right here, just getting started.
So we just read it. We just look at it. Or we write like.
You're doing that problem, right? Which relationship does not belong?
So the slope is all.
What do you think that's Y?
So what's your evidence?
Man, look at it. It's not gonna constant rate change.
It might be me.
Does relationship H have a constant?
Yes.
Or a constant?
It's more.
Okay. Okay.
That's what I was thinking.
So let's talk about it. You don't have to have the right answer. No, I won't say that yet. Just share an idea. Which one do you think is different? So remember, don't just tell me, give me a claim. I need your evidence. Why, Emma?
We said B because the rate of change for Y, it's like not even, and
Okay.
it's sporadic, and it's showing this next.
Okay, so it's sporadic, it seems. Okay, does anybody want to add on to that or push back on that?
No, certainly do not.
Is that because that's what y'all said?
Because that's what I said.
That's what y'all agreed upon? Okay.
Yes.
So Melvoria, it looks like you wanted to say something different.
A,
Why is A different?
because it's not a line, it's a circle, and I remember, Miss Moore had told us about that, where it was a circle, it's like, not really accurate or representative.
Okay. Anybody want to say something other than A or B?
Nope.
What if I were to tell you C is the odd one out?
What? I was thinking that.
I believe
You could be lying.
How?
I think you can be. I don't care.
Okay, so let's look at it. Hey, we're going to pause it and I want to point this out. Is B actually sporadic? First off,
It is sporadic.
-8 plus 0 plus 8
Remember, not sporadic. I'm
plus 16
My God.
plus 8
No.
plus 8 plus 8.
Oh my God.
That's constant.
That what I know from you. You should have worked it out.
So Anthony, what is this?
Linear additive.
Linear additive what?
No.
Rate of change.
Rate of change.
Rate of change.
Okay, look, hold on. Okay, linear additive rate of change. So it's not sporadic. You got to work these things out. It's definitely not sporadic. So what type of function is this?
That's a
Linear.
No, it's exponential.
It's
Exponential.
quadratic.
Quadratic.
Oh snap! Dude, see, they'll find that on movie now, bro.
Okay. So pause and listen. Hey, look. How about if I were to tell you that relationship D? So I'm going to come back to why. Oh, actually, so is this a line or a curve?
Neither one.
That is a line.
That's
I thought that's a curve.
No, that's a curve. Hey, look. Listen. That's a curve, right? A quadratic. Linear or curved? Curved. Right here it says that the total number of apps on his phone doubles each week. So what type of function would that be? Well, it has a multiplicative rate of change, so it's
Exponential.
exponential. Remember, an exponential function has a multiplicative rate of change. So is that linear or a curve?
It's curved.
So why is this one the odd one out?
Because it's not curved. Straight line.
Only one
Not curved.
that's not a curve.
Take another picture.
Dang, man. Mr. Kenny wasn't capping.
Okay, hold up a second. What if I were to tell you that relationship D is the odd one out?
Oh my God.
I believe you.
So we wouldn't be wrong?
Hold up, let's look up here.
It's more than one.
Look, this is x squared plus y squared equals 4. This has something where it's x squared. This has x to the first. Whereas relationship D is going to have something where it's 2 raised to the x. Notice that's the only one that doesn't have a base of x. Relationship D could be the odd one out based on that claim and evidence. It still has an exponent, so maybe the linear's one out. But again, that's the only one with an exponent of x, right? Everything else has an exponent of 2 or 1. But, I mean, relationship A is kind of unique as well because it's a circle.
They're all.
What does the X represent in that problem? The fact that you don't know how many.
Well, an x represents a variable. It can change. Remember, like if I were to look at this, he has one app on his phone. So at the beginning, he has one app. On day 1, he has 2. Day 2, he has 4. Day 3, he has 8. Right? It keeps going. So notice it's still a relationship there. Well, relationship A could be the odd one out because this is the one that's not a function. So here's what I want you to understand about math. There's not always just one right answer. You need to have claims, you have evidences. You need to look for what is similar and what is different. And I just want you to start to open your mind up to these ideas. Okay? I'll go ahead and tell you. You will not need this book Monday and Tuesday. You will need it on Wednesday. You will not need this book Monday and Tuesday. You'll need it on Wednesday. I'm going to try to get laptops up here for those who don't have an iPad on Monday. But if you have an iPad, it needs to be here and charged on Monday. Right, Owen?
My battery.
What? It's going to be here and charged, right?
I always stuck with Jason 4 block yesterday.
Ignore the daily practice assignment. We're not ready for that talk to talk. I know I blew some minds today, but I do feel like there's been some good learning even for those who say I'm not capable, right, Alasia?
There has been some good learning.
There's been some good learning for even those who don't think that they're capable.
I'm capable.
Yeah, you are. So, hey, look, one more time. Listen. I feel like there has been some good learning today, but what are all of you?
Capable of
More. Capable of more. It doesn't matter how much you've learned. You can always learn more. I am always still learning more. I am not a perfect teacher. I'm always growing.
Can you went to Starburst for? Can you went to Starburst for?
It's for my geometry students.
What them geometry students? My mom. Hey, Trick, get back.
Have a great weekend. I'll see y'all on Wednesday. But you're still going to have great learning on Tuesday. I won't put it in until today, so when are you supposed to get the progress reports?
Today?
Yeah. When are you supposed to get them in your first block? Hey, come back by or look for an email if I was supposed to give them out. I don't know if we got them yet. Jokes?
It's fine. I don't need to get grounded this weekend anyway. So.